Hello students, now I am going to discuss advanced paper 2, mock J advanced paper 2 mathematics. It again consists of 18 questions, single choice, multiple correct and paragraph type. First question, it consists of 4 independent statements. We need to check whether which statement are true. First statement is integral 0 to pi sine 2x sine of pi by 2 cosine x sine of pi by 2 cos x dx. So this is integral to 0 to pi sine x cos x sine of pi by 2 cos x. So let's say pi by 2 cos x is t. Hence it is sine x dx will be minus 2 by pi dt. This is minus 4 by pi integral sine x dx is dt, that is cos x is 2 by pi further t sin t, and limits are when x is 0 t is pi by 2 and when x is pi t is minus pi by 2, that is 8 by pi square integral minus pi by 2 to pi by 2 t sin t dt, which is an even function. Hence you can take this from 0 to pi by 2 twice 16 upon pi square, and integrating by parts you are t minus cos t minus plus sin t from 0 to pi by 2, that is at 0 pi by 2 both are 0, pi by 2 is 1, 16 by pi square. True. Statement 1 is true. Statement 2 is integral square root x minus 3 sin inverse natural log x plus cos inverse natural log x with respect to x. Now as it's an indefinite integral, let's check the domain of this function. This is x greater than equal to 3. This is defined for whenever x is greater than equal to 3, and this is defined whenever x natural log x lies in minus 1 to 1 for both. Hence x lies in e to the power minus 1 to e to the power 1. That is, these two are contradictory. Hence there is no value of x for which this function is real. Hence this is unreal function to be integrated with respect to real value. Hence it does not exist. This integral does not exist. Hence the S2 is false. What about S3? S3 is ux is integral dx over ux whole square, indefinite, and एक boundary value दी हुई है u1 is 0. You need to find ux. Differentiate both sides, you'll get u dash x is equal to 1 over ux whole square, that is ux square times u prime x, u dash x is 1, that is this, it is derivative of ux whole cube, that is ux whole cube is equal to 3x plus c, whereas u1 is 0 implies c is minus 3, that is 3x minus 3, hence ux is cube root of 3x minus 3, which is the correct choice. That is statement 3 is true. Statement 4 is question based on 3D, that is find the equation of plane passing through x-axis and perpendicular to the line x minus 1 by cos theta, y plus 2 by sin theta, and z minus 3 by 0. As the line is plane is perpendicular to this line, that is cos theta, sin theta and 0 are the direction ratios of that plane, are normal to the plane. Hence the equation must be cos theta x plus sine theta y plus 0 z equals, and as the plane passes through the x-axis means x-axis points on the x-axis lies on the plane, hence 0 0 0 lies on the plane, this is equal to 0. But for the question to be has valid data, if this plane passes through all the points on the x-axis, it must pass through any point a00 of the form a00. That means for this plane to satisfy all points of this form, cos theta must be 0 and sin theta must be 1 or minus 1. But this is the plane with this constraint, cos theta must be 0, sin theta must be plus minus 1, hence S4 must be correct. That is D option. S1, S3, S4, all of them are correct. Now let's come to question number 2. It says function x fx satisfies f of negative x times f dash x is same as fx times f dash minus x. Boundary value f0 is 3 and we need to compute the indefinite integral. Now according to this condition, if you take these two terms, this term to this side, and by observation you can say it is derivative of d by dx of f negative x and times fx. Keeping this as it is derivative of this, keeping this as the derivative of this is this term is equal to 0. That implies f negative x times fx must be constant and this must be same as f0 square, taking x as 0. As we know the value of 0, value at 0, that is 9. F of negative x times fx is 9. Now to compute minus 2010 to 2010 dx over 3 plus fx, it must be, let's say it is I, this must be same as minus 2010 to 2010. If we replace x with minus x, this is dx over 3 plus function value at minus x. The function value at minus x comes out to be 9 over fx, hence it is integral fx over 3fx plus 9 from minus 2010 to 2010. Multiplying with 3 in numerator and denominator, that is 9 plus 3fx. This is also I, this is also I. Adding these two i's, you will get left with 2i is equal to integral minus 2010 to 2010 3 plus fx by thrice common 3 plus fx dx, that is 1/3 of 4020. That is, hence I must be 670. That is D option. Easy one. Question 3. It says if z-axis is vertical, z-axis is vertical, the equation of the line of greatest slope through 2 minus 1 0 on the plane. That is, there is a plane (2x plus 3y minus 4z equals 1) and there is a point on it 2 minus 1 0. And we need to find the equation of the line passing this point having the greatest slope. Now, line having greatest slope is defined as, if we consider, let's say there is a horizontal plane that is this plane is parallel to xy plane, or you may take this as the xy plane. Now line passing through this could be many. This line of greatest slope is defined as line passing through this point and is perpendicular to the line of intersection of this plane with the horizontal plane. This line is considered as the line of greatest slope. Now let's compute this line. As line is passing through this point, line must be of the form x minus 2 upon a, y plus 1 upon b, z by c. Now this line is lying on this plane, hence direction ratio of this line dot product with direction ratio of normal to the plane must be 0, that is 2a plus 3b minus 4c must be 0, first equation. Further, we need this line to be perpendicular to the line of intersection with the xy plane. Now line of intersection with the xy plane has direction ratio which are proportional to cross product of the direction ratio of the normal to xy plane and this plane, that is I cap, j cap, k cap. Direction ratio of this plane must be 2, normal to this plane must be 2, 3, minus 4, and direction ratio of the xy plane must be 0, 0, 1, normal to the xy plane, which are proportional to 3, 0, 0, 1. Okay, 3, then 3 I cap minus 2 j cap. Now this line must be perpendicular to the line of this intersection, that is 3a minus twice b must be 0. Second equation. Solving these two, you will get ABC must be proportional to 8, 12 and 13. 8 by 8, b by 12 and c by 13. A by 2 is b by 3. A by 2 is b by 3, and you can get c from here. That is a by 8, b by 12, c by 13, hence the equation is x minus 2 by 8, y plus 1 by 12 and z by 13 as the answer. That is D option. Question 3 is again D. Now coming to question number 4th. It says a and b are two positive coprime integers and limit n approaches infinite 3n cn by 2n cn to the power 1 upon n is given to be a by b. We need to find a plus b. Now this will be equal to limit n approaches infinity 3n factorial over n factorial 2n factorial divided by 2n factorial over n factorial to the power 1 over n, which is equivalent to limit n approaches infinity 3n factorial times n factorial over 2n factorial square to the power 1 upon n. Now this will be equivalent to limit n approaches infinity you are left with 3n minus 1, 3n minus 2 up till 2n plus 1, and cancelling this n factorial with 2n factorial, we are left with 2n minus 1, 2n minus 2 up till n plus 1, whole to the power 1 over n. Rotating from right to left, it is limit n approaches infinite 2n plus 1, 2n plus 2, 2n plus 3, so on and so forth till 2n plus n. N factors in numerator divided by n plus 1 n plus 2, n plus 3, n plus n. N factors in denominator to the power 1 by n. Now, if this limit is, let's say, y, taking log of both sides, you will get log y is equal to limit n approaches infinity 1 over n summation log of 2n plus 1, 2n plus r upon n plus r varies from 1 to n, which is equivalent to limit n approaches infinity 1 over n summation natural log of 2 plus r upon n upon 1 plus r over n. R varies from 1 to n, which is equivalent to integral natural log 2 plus x over 1 plus x dx from, if we take r by n, at r is equal to 1 it is 0, at r is equal to n it is 1. Natural log y is equivalent to this. Now integrating it by parts, you will get 27 over 16 as the answer, treating one as one as second function. Now hence y must be e to the power 20, it is ln of 27 by 16, hence y must be 27 by 16. That's it. That is, answer for this question is 27 plus 16, that is 43. Now let's come to question number 5th. It says there is a transcendental equation x to the power 4 plus 3 cosine ax square plus bx plus c equals twice of x square minus 2. It has two distinct solutions. Further, it is given that these three coefficients a, b, c belongs to 2 to 5. We need to find the maximum value of ac by b square. Now, let's take polynomial part this side, that is x to the power 4 minus 2x square, let's say plus 4 is equal to minus 3 cosine ax square plus bx plus c. Now this is completing the square, x square minus 1 whole square plus 3, that is minus 3 1 plus cosine ax square plus bx plus c. Hence it is minus 3 times 2 cos square theta by 2 ax square plus bx plus c by 2. This is x square minus 1 whole square. Now this side is LHS is clearly greater than equal to 0 and simultaneously RHS is less than equal to 0. Hence for this equation to have solution, both must be 0. Both must be equivalent to 0. Hence you are left with x as two distinct solutions, x is equal to plus minus 1. Right? For x is equal to plus minus 1, this side is 0, this must be also 0. Hence you are, that is cos of, let's say take this previous one, that is a plus b plus c must be minus 1 and simultaneously cosine of a minus b plus c must be minus 1. Now that is a plus b must be an odd multiple of pi and a minus b plus c must be again an odd multiple of pi, and as ABC belongs to 2 to 5, let's take the range of a plus b plus c. A plus b plus c take values in minimum 6, maximum 15, and a minus b plus c must be minimum a and c both must be 2, b must be 5. 2 plus 4 minus 5 minus 1, and for maximum a must and c must be 5, b must be 2, 8. A minus b plus c must be minus 1 to 8. Now as a plus b plus c must be an odd multiple of pi, and along with this a plus b plus c lies in 6 to 15, these two equations simultaneously implies a plus b plus c must be 3 pi. Lying in 6 to 15, the only solution, and a minus b plus c must be, it is again a multiple of pi, 3 pi minus pi. This is only pi. And that is a minus b plus c must be pi. From these two equations, we are twice of a plus c is 4 pi, hence a plus c must be 2 pi. A plus c must be 2 pi, hence b must be pi. That is a plus c by 2, which is pi, must be equal to b, and a and c are positive number. This a plus c by 2 must be greater than equal to root ac. Hence you can say AC by b square is always less than equal to 1, and this equality holds when a, b, c are all equal. A plus c must be a and c are equal, a and c are equal, a and c must be pi, and b is also pi. All of them are equal. The only possibility. That is a option. Fifth answer key for fifth is a. Sixth question. It says capital M as sigma k varies from 1 to 59. Minimum of function at k by 30, function phi of k by 60, okay, and function phi is defined as phi x is minimum of x minus integral x and integral x minus x plus 1. Now let's compute first function phi x. Now this one is fractional x, and taking minus common from this is again 1 minus fractional x. Now let's plot the graph of this. Both are periodic function of period 1. Fractional x is 0 to 1 like this. From 1 to 2 it is like this. 2 to 3 it is like this. Minus 1 to 0 is like that. And 1 minus fractional x is negative of fractional x is like this. And added 1, that is taking 1 upwards, as it is like this. Now this one is, and this is like the minimum of the two is the graph which is nearer to x-axis. That is, minimum of the two must be of this form. That is, from 0 to half. 0 to half it is x, from half to 1 it is 1 minus x. From 1 to 3 by 2 it is x minus 1, from 3 by 2 to 2 it is 2 minus x, and so on and so forth. Now the graph of function x phi x is clearly symmetric about y axis, symmetric about half as well, symmetric about 1 as well, and so on. That is, this is symmetric about n by 2. It is symmetric about n by 2 for every n integer, for every n belongs to I. That is, you can say it is phi of n by 2 minus x is phi of n by 2 plus x. N can be any integer. It is symmetric about n. Now let's come to m part. Now it says m is minimum of it's a summation of k varies from 1 to 59 of this. Now let's expand this. Minimum of phi of 1 by 30, phi of 1 by 60 plus minimum of phi of 2 by 30, phi of 2 by 60, and so on and so forth till minimum of phi of 59 by 30, comma 59 by 60. Now, according to this part minimum of 59 by 30 and minimum of 59 by 60. 59 by 60, you can write this 59 by 30 as 1 minus 2 minus 1 by 30, phi. And you can write this as phi 1 minus 1 by 60. And as you see over here, it is symmetric about origin 1 by 2, 1, 2 and so on. Phi of 2 minus 1 by 30, phi of 2 minus 1 by 30 is same as phi of 1 by 30. That is, this expression, this value will be same as phi of 1 by 30. In the similar manner, phi of 1 minus 1 by 60, phi 1 minus 1 by 60, phi of 1 minus 1 by 60 will be same as phi of 1 by 60. That is, this expression is same as this expression. That's it. That means this function will be same as minimum of these two values will be same as minimum of these two values. That is, you can say phi of r by 30, phi of r by 30 is same as phi of 2 minus r by 30. That is 60 minus r by 30. And similarly, phi of r by 60 will be same as phi of 1 minus r by 60. Hence, first term is same as second term. Similarly, first term is same as first from the last term. Second term is same as second last, and so on and so forth. Middle term must be when k is at 30. Now let's compute that. When k is 30, you are minimum of phi of 30 by 30, comma phi of 30 by 60. Now 30 by 30 is 1. Phi of 1 is 0. And it's a non-negative function. So clearly, minimum of these two must be this only, that is 0. Hence, at 30th term, this term will be 0. That is, we are left with first 29 terms. And let's double it. This will be equal to twice summation k varies from 1 to 29, minimum of phi of k by 30, comma phi of k by 60. Okay. Now just observe that when x is less than half, whenever x is less than half, from 0 to half, phi of x is x only. That is, till when k is 15, when k is 15, phi of 15 by 30 is 15 by 30 only, and this must be 15 by 60. And of these two minimum will be this only, till 15th. But going forward, let's say at 16th value, when k is 16, it is phi of 16 by 30, phi of 16 by 60. Now, what is phi of 16 by 30? 16 by 30 is less more than half. That is, phi of 16 by 30 must be 1 minus 16 by 30. That is 14 by 30. And this must be 16 by 60 only. That is 8 by 30. And of these two, again, minimum will be this only, as in first 15 terms. That is, at 16, again, minimum will be this only. Hence, going forward till 20th term, when k is 20, this will be phi of 20 by 30. And this will be phi of 20 by 60. This is 1 by 3, less than half, and this must be 1 minus 20 by 30, that is again 1 by 3. And minimum of the two is any of them. Hence, till 20th term, minimum will be this. Hence, let's split it into two summation. K varies from 1 to 20. Minimum will be this, that is phi of k by 60. Plus, let's check for 21st. For 21st, when k is 21, it is phi of 21 by 30 and phi of 21 by 60. This is nothing but 21 by 60, less than half. x. And 21 by 30, for this you have 1 minus 21 by 30, that is 9 by 30. 9 by 30, which is 18 by 60. Lesser of them will be this one only. Now from 21 onwards till 29, minimum will be this. That is summation k varies from 21 to 29. We are left with phi of k by 30. This must be twice of, now summation phi of k by 60 is nothing but k by 60. K by 60 summation 1 to 20 plus 21 to 29 summation phi of k by 30 is 1 minus k by 30. That is twice of 1 by 60 times 20 times 21 by 2 plus 1 by 30 times, it is 30 minus 21, 9 till 1, summation 1, 9. That is 9 times 10 by 2. It is coming out to be 7 by 2, and this one is 3 by 2, 10 by 2. Hence twice of 10 by 2 is 10. A fairly difficult question again, difficult question. Option is B. Question number 7, multiple options, correct options, multiple correct options. It says f is a function that satisfies the functional equation fx plus y is equal to fx plus function value at y plus x square y plus x y square for every real x at y, and there is a limit given, limit x approaches 0 of fx by x is given as 1. Now from this equation, if I take x and y both 0, if we let x and y both 0, you are left with f0 is equal to twice f0, hence that implies function value at 0 must be 0, and that suggests this value is f dash x, f dash 0. Now going forward, f dash x is, using first principle, it is limit h approaches 0, f of x plus h minus fx over h, which is limit h tends to 0, f of x plus h minus fx must be fh plus x square h plus xh square by h, which is distributing h to these three terms, you are left with fh by h. This only 1 plus x square plus 0, that is 1 plus x square. F prime x is 1 plus x square, hence fx must be x plus x cube by 3 plus c, whereas f0 is 0 implies c is 0. That is function x is x plus x cube by 3, which is x common, you are left with 1 plus x square by 3, whose sign scheme must be positive, negative. That is when x is positive, fx is positive, and x is negative, fx is negative. That is the first option. First is correct. Option A is correct. Derivative at 0 is clearly 1, f prime 0 is 1, which is already given to you, and double derivative at 0 is 0, and triple derivative at 0 must be 2. C and D are incorrect. Easy one. Question number 8. It says function x is sine to the power 5x plus cosine to the power 5x minus 1 in the domain 0 to pi by 2 first quadrant. You need to discuss monotonicity of f and some values, some function properties. Now f dash x is 5 sine to the power 4x cos x minus 5 cos to the power 4x sin x. Taking 5 sin x cos x common, we are left with sin cube x minus cos cube x, which further can be written as 1 5 sin x cos x times sin x minus cos x, and sin square x plus cos square x 1 plus sin x cos x, which is clearly a positive function, always positive. Now that is roots of this, please, roots of sin x cos x, sin x minus cos x under this interval. Now let's break this interval 0 to pi by 2. Sin x or cos x are 0 at 0 and pi by 2 only. Sin x minus cos x is 0 at pi by 4. Now from 0 to pi by 4, sin x is less than cos x, and from pi by 4 to pi by 2, sin x is more than cos x. Hence from 0 to pi by 4, this is negative, both are positive. So it is negative, and over here it is positive. That is, function decreases in 0 to pi by 4 and increases in pi by 4 to pi by 2. That is, if I draw the graph of this, it will be like this. 0 is critical, pi by 4 is critical, pi by 2 is critical. At 0, derivative is 0, pi by 4 will be 0, pi by 2 will be 0. And at 0, function value is sin 0 0, cos 0 1, 1 minus 1 0. That is, it starts from here. Derivative at 0 is 0. It will be like this. Pi by 4 it will be 1 by root 2 to the power 5, 2 by root 2 to the power 5 minus 1. Somewhat like this. 2 by root 2 to the power 5 minus 1, and like this. Graph of fx. Now that's it. F is strictly decreasing in 0 to pi by 4, true. F is strictly increasing in pi by 4 to pi by 2, true. There exists a C in 0 to pi by 2, so that F dash C is 0. This is the C, pi by 4 only. And F dash C is 0, and the equation Fx equal to 0 has only two roots in the entire domain, 0 in the interval 0 to pi by 2. These are the only two roots, true. All of them are true. Question 8 has answer key A, B, C, D. All are correct. Question 9th. It says T and Ft be the eccentricity of the ellipse. T is eccentricity of the ellipse, x square by 3b square minus 2a square plus y square by 2b square minus a square is equal to 1, and function t, these are eccentricities. Eccentricity of the ellipse, x square by 2b square minus a square plus y square by b square equals 1. It is further given that b square is more than a square. B square is more than a square. If b square is more than a square, clearly this value must be more than this value, as rearranging will give you only b square minus a square. This minus this is nothing but b square minus a square. Similarly, this minus this is again b square minus a square. Hence, both are horizontal ellipses. Both are horizontal ellipses. Now let's say t square must be, e square is 1 minus b square by a square. Hence, t square must be 1 minus minor square, that is 2b square minus a square, upon semi-major square, that is 3b square minus twice a square. This is coming out to be 3b square minus 2b square, b square minus 2a square plus a square minus a square upon 3b square minus 2a square. And in the similar manner, function t whole square will be 1 minus b square upon 2b square minus a square, which is 2b square minus a square minus b square minus a square over 2b square minus a square. Now, as you can see, observe, this term minus this term will be same as this term. That is, if I apply alternando, or this is, you can say this is t square upon 1 minus t square. This will imply t square upon 1 minus t square must be same as b square minus a square upon this minus this, that is b square minus 2a square plus a square minus 2b square minus 2a square plus minus a square, which is same as this expression. Hence, ft square is this. t square is this. Hence ft is given by function value at t is square root of this, and t and ft both are positive. Hence you can say ft is t upon under root of 1 minus t square. That is function value at t. Hence A is incorrect. Let's compute function of function. F of f at ft. F of ft is t upon root 1 minus t square upon root under 1 minus t square upon 1 minus t square. That is t upon under root of 1 minus 2t square. Let's compute function at function t. Must be t upon under root of 1 minus 2t square upon under root of 1 minus square of this, that is t square upon 1 minus 2t square, is again coming out to be t upon under root of 1 minus 3t square. Hence it is clear that function of so on and so forth, function t, if it is taken n time, must be t upon under root of 1 minus nt square. Okay. Hence B is again incorrect. C option is integral 0 to half f o f t taken 4 times dt. This must be integral 0 to half t upon under root 1 minus 4t square dt. Now let's take 2t as sin theta. That is 2 dt sin cos theta d theta. That is integral cos theta d theta. T is sin half sin theta. This will be 2 dt cos theta by 2 another 4 d theta upon under root of 1 minus n square, that is mod cos theta. And when t is 0, theta is 0. When t is half, theta is pi by 2. And 0 to pi by 2 cos theta get cancelled, that is 1 by 4. C is correct. And what about D option? D is integral e to the power t ft minus f double dash t, which is integral e to the power t adding ft and f dash t and subtracting f dash t, ft plus f dash t minus f dash t minus f double dash t. Its derivative is this, its derivative is this, hence the integral will be, answer will be e to the power t times ft minus f prime t. Now ft was t upon under root 1 minus t square, and derivative of this just computed. Answer option D is correct. Hence question 9th answer key is C and D. Difficult one. Question 9th is difficult one. Let's come to question 10th. It's given a real valued function f defined as tan square fractional x over x square minus greater than x square when x is more than 0, 1 when x is 0, and is under root of fractional x times cot fractional x when x is less than 0. We need to find some properties, limits, and okay. Now let's say limit x approaches 0 plus of fx. First option, limit x approaches 0 plus of fx is limit x approaches 0 plus of this function, that is tan square fractional x over x plus greatest integer x times x minus fractional x minus greater x. Now x is just near to 0, then fractional x must be x, just positive side of 0, and greater x must be 0. Hence this will be equivalent to limit x approaches 0 plus tan square x over x square, that is 1. Option A is correct. Similarly, limit x approaches 0 minus of x is this one, that is limit x approaches 0 minus of under root of fractional x times cot fractional x, which is limit x approaches 0 minus of, it is x minus minus 1, that is x plus 1 cot of x plus 1, and x is nearly 0, it is root of cot 1. Root of cot 1, hence B is incorrect. B is not correct, it is given as cot 1. Option C is just using this. Option C is using this. You have cot inverse of square of this limit, that is root cot 1, that is cot 1. It is clearly 1. Cot inverse of cot 1 is 1. From 0 to pi it will take same value. And similarly tan inverse of first limit, tan inverse of first limit, that is 1. This is clearly pi by 4. True. C and D are true. Easy one. Let's come to question number 11. It says fx is a strictly monotonic differentiable function on 0 to 1. Strictly monotonic differentiable function in 0 to 1. Okay. And further it says f0 is 1 and f of 1 is minus 1. It's a strictly monotonic differentiable function. Further, we need to compute twice integral minus 1 to 1 of x f inverse x minus 1 dx. We need to compute this in terms of fx. Now let's put f inverse x as function. Let's say f inverse x as t. It's a 1-1 function, so you can take f inverse x as t. You can say or x as ft. Hence twice integral minus, okay, that will be ft times f inverse x t minus 1. Dx will be replaced with f dash t dt. F prime t dt. And over here it is f inverse minus 1 and here it is f inverse 1. F inverse minus 1 must be 1 and f inverse 1 must be 0. That is, we are left with twice integral 1 to 0 t minus 1 ft f prime t dt. That is, taking by parts, first function, second function, twice integral t minus 1 integral of t f dash t will be ft whole square by 2 minus derivative gone half integral 1 to 0 ft square dt. Taking parts, taking limits on this part, 1 to 0, add 0, it is coming out to be minus f0 square. F0 was 1 minus half, at 1 it is 0, twice of this, minus half integral 1 to 0 ft square dt. That is, finally it is coming out to be integral 0 to 1 ft square dt minus 1. That is a option. Now, as function is differentiable as well as strictly decreasing function, bounded function from 1 to minus 1, range is minus 1 to 1. Clearly, integral from 0 to 1 fx dx exists, which is nothing but area bounded by this minus this, that is A minus B. This area is A, this is B. Clearly exists. And C is incorrect, B is correct. And what about D? D is integral twice of this, which is finally comes out to be this 0 to 1 ft square minus 1. What about fx square? Graph of fx square must be like this. From this point, something this, maybe somewhere here, at minus 1 square will be 1, like this. This is the graph of fx square. And integral of 0 to 1 fx square dt will be this area plus this area. Must be less than this 1 by 1 square. Hence minus 1 must be, this must be negative. Hence area must be negative. This integral twice 0 minus 1 to 1, this one is clearly negative, hence D is incorrect. Options are A and B only. Coming to question number 12th. It says S is the set of all x that x is summation of iota to the power j. J varies from n to m, whereas n and m both belongs to set of integers. You need to find number of elements in S, or cardinality of S. That is, S consists of all the elements of the form iota to the power n plus iota to the power n plus 1, iota to the power n plus 2, so and so forth till iota to the power m, where m and n can take any integer values. Now, we don't know m and n. Let's start with integral powers of iota. Iota to the power 1 is one possibility. If we take n as 1 and m as 1, then we have n as 2, m as 2, we have iota square, iota cube, iota to the power 4. These are the four powers of integral powers of iota, possible powers. Now sum of two integral powers of iota, let's say iota to the power 1 plus iota square, iota 1 plus iota 2 plus iota 3, iota 3 plus iota 4, iota 4 plus iota 5, which is equivalent to 1. Then sum of three integral powers of iota, that is iota to the power 1, iota square, iota cube, so and so forth till iota 4 plus iota square. And similarly, last one is sum of all four parts of integral parts of iota, that is iota to the power 1, 2, iota to the power 4. Now, these are not, all of them are not distinct. Now, let's say this is iota plus iota minus 1, somewhere else there must be iota minus 1. But altogether, if you compute all these values, there are 9 such elements, 9 different elements in this set, and that is your option B. Only single correct. Coming to question number 13, it says f is a continuous and 1-1 function. Continuous and 1-1 function for every x greater than or equal to 0. And there is an inequality 0 to x ft dt is less than x by 2 f0 plus fx. Now this itself suggests it is area using trapezium. Now graph of, let's come to graph of this. Now let's say if at 0, f0 is here somewhere here, and let's say at x, which is more than 0, and let's say fx is here. And it's given that it is continuous and 1-1. As it is continuous and 1-1, it must be, let's say, if I join these 2 points, area bounded by this line with x-axis is clearly half sum of the parallel side, that is f0 plus fx, and distance between these two, that is x, which is right hand side. It says area bounded by function from 0 to x. Area bounded by the function from 0 to x is clearly less than this trapezium area. Hence, it starts from here and at here. It's a 1-1 function. It must be below this. And it's a 1-1 function as well. Hence, it must be below this. And similarly, there is a second possibility. If f0 is more than fx, in this similar manner, graph will be like this. In both the cases, clearly it is convex down. Hence, in both these cases, double derivative is positive. Double derivative is positive. In this case, f dash is positive, f is increasing, double derivative is positive, and in this case, f is decreasing, hence f dash is negative, f double dash still positive. That is, f dash is negative, f double dash positive, f dash is positive, f double dash is positive. That is B and D. Answer K is B and D. Question 13th. Easy one. Now let's come to question number 14th. It says ABC represents the vertices of a triangle. A is origin. A is origin. A, B, C are the vertices of a triangle. A is origin. B and C have position vectors small b and small p. Further, it says points M, N and P are taken on the sides AB, BC, CA respectively. AB पे M है, BC पे there is a point N, and at CA there is a point P. Not necessarily they are inside, let's just take one case when these are inside. Further, it says AM upon AB is same as BN upon BC is same as CP upon CA as alpha, which is not 0 or minus 0. Hence alpha can be positive or negative. I have just taken alpha as positive. I just consider the case when alpha is positive. That is, AM upon AB is alpha, means AM upon MB must be alpha is to 1 minus alpha. Similarly, BN upon NC must be alpha is to 1 minus alpha. Similarly, CP upon PA is also alpha is to 1 minus alpha. Hence, position vector of M and P are there. We can find position vectors of M, N and P. That is, position vector of M comes out to be alpha B, just alpha B. Position vector of N comes out to be alpha C plus 1 minus alpha B. And position vector of P comes out to be 1 minus alpha C. Now coming to the options, AN vector plus BP vector plus CM vector. AN vector is position vector of N only, that is alpha C plus N. AN vector plus BP vector plus CM vector. AN vector is alpha C plus 1 minus alpha B, alpha C plus 1 minus alpha B plus BP. BP is P minus B, that is 1 minus alpha C minus B plus CM. CM is position vector of M, that is alpha B minus C. It is alpha C minus alpha C gone, plus C minus C gone, minus B plus B gone, minus alpha B, that is null vector. It is clearly null vector. A is correct. If delta represents the area of the these three vectors, that is, delta is area of these any of the two vectors, that is half let's take this one with this one, and that is modulus of alpha c plus 1 minus alpha b cross product with alpha b minus c. It is coming out to be half alpha square c cross b minus 1 minus alpha b cross c, which is, you can say it is b cross c, this is also b cross c, that is half modulus of plus alpha minus 1. It is minus alpha square minus alpha plus 1 mod and modulus of b cross c. And as for any alpha, this must be positive. D is negative, hence you can say it is half alpha square minus alpha plus 1 modulus of b cross c. That is, B is also correct. C is value of alpha for which area is least. Now the value of alpha for which area is least, this depends on this alpha only, and critical point of this is half only, and it's a point of minima. Hence value will be least when alpha is half, true, C, and D is obviously incorrect. Now coming to question number 15, 16th part, passage type. It says there is a conic ax square plus 2hxy plus by square is equal to 1. Ax square plus 2hxy plus by square equals 1. It's a conic section, and there is a circle x square plus y square is equal to r square. If they intersect at 4 points, let's say this conic is like this and circle is like this. If they intersect at 4 points A, B, C, D, then obviously we can have any conic passing through these 4 points. Can be this plus lambda times of this. This will be this plus lambda times of this. Okay. Now it just eliminated one. That is, this r square is equal to 1, and subtracted. That is a minus 1 over r square x square plus 2hxy plus b minus 1 by r square y square is equal to 0. This is also the conic passing through the intersection, these 4 intersection, but clearly it's a homogeneous equation, hence it must be pair of straight line through origin. That is, could be AC and BD. Now this will represent two coincident lines provided if this circle touches this ellipse. In this case, let's say if the ellipse is like this and if circle touches this ellipse, then these two lines will represent single line. Or in the similar manner, if the circle touches the ellipse from inside, like this, then it is minor axis. That is the case. Now let's come to the question part. 15th. It says length of the major axis and minor axis of the given ellipse. Now the given ellipse is 5x square. Given conic is 5x square minus 6xy plus 5y square plus 22x minus 26y plus 29 equals 0. We need to find the length of the major and minor axis of this conic. Now, as this is not in the standard form, well, this form, particular form, now if I consider this as function phi, then solving del phi by del x and del phi by del y will give you center of this conic section, and which is given as, solve these two equations, you will get to point as minus 1 comma 2. Solving this we'll get point as minus 1 comma 2. Let's shift the origin to this particular point, that is, let x is equal to x minus 1 and y equals y plus 2. Shifting origin to this particular point, convert this equation in the form 5x square minus 6xy plus 5y square. No change in this part, notice this, and these two terms will be gone and is equal to 8. Now let's eliminate this 8 using circle. You have left with 5 by 8 minus 5 by 8 minus 1 by r square x square minus 6xy plus 5 by 8 minus 1 by r square y square is equal to 0. Or hence, for this equation to represent major axis or minor axis, coincident major axis or minor axis, you must be 5 by 8 minus 1 by r square time 5 by 8 minus 1 by r square must be equal to h square, that is 6 by 8, 3 by 8 square, that is 9 by 64. Solving it, you will get r square as two values, that is 1 or 4. Hence r can be 1 or 2. Hence 2a is 4 and 2b is 2. Length of major and minor axis, which is your option C. For 15th you have option C. For 16th part, you need to just take r square as 1 in this equation. Take r square as 1 in this equation, you are left with 5 by 8 minus 1. If I take r square as 1, 5 by 8, taking value of r square, 5 by 8 minus 1 x square minus 3 by 4 xy plus 5 by 8 minus 1 y square is equal to 0. That is minus 3 by 8 x square minus 3 by 4 xy minus 3 by 8 y square. That is x square plus 2xy plus y square is equal to 0. That is x plus y whole square. That is, one line is this. When r square is taken, that is, it is minor axis. That is x plus y. The point was minus 1 comma 2. It is 1. One line is this, and the another line must be, this is minor axis, and major axis must be, when we take r square as 2, you will get second line as x minus 5 plus 3 is equal to 0 as the major axis, which is given in option D. It's a difficult one. Let's come to passage number 2, question number 17th and 18th. It is simpler one. Probability of union of two events A and B is given as greater than or equal to 4 by 5, and probability of A intersection B is lying in 1 by 10 to 3 by 10. Now from these two equations, it says if you need to find area bounded by set of all the points PA, PB. Now from these two equations, P of A plus P of B, which is probability A union B plus probability of A intersection B, we can get range of this, that is PA plus PB. Maximum value will be when this is maximum and let's say this is minimum, but in that case we need to take union of the complete interval, that is probability of A union B lies in 4 by 5 to 1. Minimum, it is maximum is 1 plus 3 by 10, and over here it is when this is 4 by 5 and this one is least at 1 by 10. that is, it is coming out to be 8 plus 9 by 10, and this one is 13 by 10. PA plus PB is lying in 9 by 10 to 13 by 10. Now let's do it geometrically. PA and PB both are probabilities and both of them complete exhaustive set is 0 to 1 individually. Now let's take PA along x-axis and PB along y-axis 0 to 1. That is, this is the sample space. PA and PB lies in 0 to 1 individually, and PA plus BB lies in 9 by 10 to 13 by 10. Hence, if it is PA plus PB, that is x plus y. If it is 9 by 10, it is 0.9, somewhere here. 9 by 10, 9 by 10. And this is more than this, that is area above this line. And in the similar manner, x plus y, when it is 13 by 10, 1.3, here somewhere here. 1.3. That is, and x plus y is less than equal to 13 by 10. It is less than equal to, it is more than equal to. That is area less than this. That is, this area is favorable region, which is given by, you need to find just area. Area of this will be 1 minus this triangle minus this triangle, that is twice of, this is just half of 9 by 10 times 9 by 10, 81 by 100, plus this is 1, and this line is x plus y is equal to 13 by 10. And this must be, when x is 1, y is 3 by 10. This is 3 by 10. This must be 7 by 10. That is 49 by 100. That is coming out to be 130 by 100, 13 by 10, 13 by 20. 1 minus 13 by 20 is coming out to be 7 by 20. 7 by 20 square units, that is C option. Coming to 18th part, question number 18th. It says a point QXY be selected from the region which is given as x square plus y square is less than equal to 2, where x and y both positive. That is a quarter of a circle of radius root 2, 1.4 somewhere here. One plus 1, 2, passing through this point. This is root 2. And what is the probability that point belong to the region defined above? That is, we need to find the area of this divided by area of this quarter. That is nothing but 7 by 20 upon area of the quarter, that is pi by 4 r square 2. It is coming out to be 7 by 10 pi. 7 over 10 pi, that is option D. That's it. Again, this paper has roughly 10 easy questions. Comparatively to paper 1, it is difficult. It has 10 easier questions that are 1, 2, 7, 8, 10, 12, 13, 14, 17 and 18, the last two. And moderate ones are 3, 4, 5, 11, 15, 16, and difficult ones are 6 and 9, which involves calculation. Thank you.